right, good morning, everybody here in Chicago. Good afternoon, good evening to folks watching online. My name's David Steele. I'm our program manager for post-incident transparency. That means we're here today to talk about outages. I know a lot of Ignite is selling the sizzle of how great the Microsoft Cloud is and how great Azure is, and that's true, but we want to make sure that we're really representing the full spectrum of the experience of life on Azure. So we're going to be here to talk about reliability, both in terms of what the Microsoft stack does for our platform reliability and what you as customers can do for application reliability. So I'm joined here today by Sujay, who's going to be running us through some demos to help make this real, and my co-host here, Sami Kubba.
Super, thank you. So my name is Sami Kubba. I'm on the Azure Outage Communications team. This is the team that communicates impactful events to customers. This could be a retirement of a feature or service. It could be a planned maintenance event, or in the worst case, it could be an outage. And outages are inevitable, like death and taxes. And so it's really about how we deal with things. If we ask ourselves, well, how reliable is Azure? It's a really tricky question to answer. We don't have a great answer. But if we were to reach into Azure and take a virtual machine and look at it and say, how reliable is this virtual machine? And the best we have right now is to say, well, its availability is 4 nines and an 8. And there's a few ways to look at this. One of the ways to look at this is to say 4 nines and an 8 isn't bad. It translates to about 10 minutes of downtime a year. No other major cloud provider has hit the 5th nine, although everyone's getting a little bit closer. But if we take that 10 minutes of downtime a year, some customers will say, 10 minutes of downtime a year, I'll take it. Sounds like a great deal. But another way to look at this, if 10 minutes of downtime a year could mean 1 minute of downtime every 5 or 6 weeks. Or it could mean every 3 or 4 weeks, you have a 30-second interruption. And that interruption is enough to kick your SQL database off your VM, your app has to restart, and it's a whole thing. And so someone's sitting down saying, hey, I'm having issues every 3 or 4 weeks. And you say, what are you talking about? We're 4 nines and an 8. We're amazing. All of this to say that availability is not the best indicator of reliability. And as an industry, we're moving away from just pure uptime numbers into creating better service level indicators so we can create better service level objectives so that we can kind of prep this in a healthier way. We all know why bad things happen. We're not going to talk about software having bugs and people making mistakes and hardware failing. That's part and parcel of our industry. But really, really, when we look at why bad things happen, it's a series of contributing factors or a series of unfortunate events. And I think it's such a healthy thing to look at it in this way, because the default position for all of us in the IT world following some sort of major outage is to reach into the layer that we know the best, because that's the layer we're going to analyze. We're going to take one of these holes and we're going to conduct a 5 whys exercise on it. And we sit down in a room asking ourselves, why, like my 9-year-old does. And we're asking about one of the holes in one of the layers. And really not being able to stand back and take a deeper assessment or a broader assessment of this will lead us down the wrong path. And the reason I like this is because this applies to things outside of outages. I look at the political landscape around the world, and I look at the rise and fall of new politicians, and they say, why did it happen? And it would be a fool's errand to say, well, it was to do with it was celebrity endorsements, or it was the other party. It's usually a series of contributing factors, and so understanding these will make a better use of our time. David, how are we going to plan the rest of this session?
Yeah, so this is kind of how we'll break it down for today. We're going to start talking about the shared responsibility model here. So obviously, if you want your applications to be reliable on Azure, we've got to hold up our end of the bargain. That's this bottom rung here. So this slide's probably best read from the bottom up. We're going to talk a little bit about the resilient foundation of Azure. We're going to talk about how we design, operate, and monitor Azure to ensure the best reliability possible. And then particularly when we get into some of the demos, Sujay's going to be running through these resiliency features that might not necessarily be on by default, but for things like high availability, disaster recovery, these are things that you can take advantage of in the platform to make sure that you're more reliable. We won't spend as much time on the very top tier today. There are a lot of sessions at Azure throughout Ignite that will cover the application architecture in a huge amount of detail. So we're going to try to kind of front load this into these bottom 2 sections. So if we just zoom into that bottom layer, that resilient foundation, for Microsoft, that's really our responsibility, the reliability of the cloud. And the tiers above that, that's reliability in the cloud, that's your responsibility, but obviously we help and support you in implementing those things. So for this bottom rung, there's a few different ways to think about the reliability of the Azure platform itself. We're going to run through our infrastructure, some hardware stuff. Sami and I will give you a bit of a tour of each of these different layers to talk about reliability investments. Then we'll pivot over to talk about our processes. We'll talk about change management, incident management, AI ops, before we get a little philosophical and wax lyrical on what happens when some of our principles collide and how we prioritize there. So with that, I'll start our tour, and Sami will start us off at the networking layer, and we'll zoom in.
Super, thank you very much. I always like to think of these on the right-hand side as the ingredients of Azure. If customers wanted to build an Azure themselves, what would they need? Well, they need some networking, some regions, some zones, data center, storage, compute, so on. And so really at each of these layers of our ingredients, we have built resiliency and we've built reliability into it. If we start at our networking layer, if we look at the 60+ regions that we have and hundreds of data centers, each of these regions and each of these data centers are connected to our network, which connect to each other. And they have to connect to each other in a way that everything is connected, that we have utilization, we have paths that can be utilized in the case that the paths go down, because we know that things are going to go down. And so the way that we look at this inside a data center itself is we kind of take the rule that every device within a data center needs to be connected to every other device. They should have multiple paths and multiple routes for redundancy, and data should always traverse in the quickest route, which is fine. As we make changes to our network, this network is constantly shrinking, growing. We decommission old hardware. We're adding in new hardware. You've all been to Ignite. You've seen the scale of the things that we're doing. This thing is under constant movement. There's constant changes happening. And so the way we manage these changes, particularly with our network, we have kind of two main systems. One is called One, the Open Network Emulator. And that's where we've taken our entire network and we've emulated onto a ton of virtual machines. And we're able then to kind of look, and as we provision out, kind of see what happens and see how our designs are going to be, how any change will impact these. Then the real interesting one is called our real-time operations checker. And this is what happens when we sit down and we can say, we're about to add these new IP addresses right now. What's going to happen? And in real time, it shows us with live traffic. So the Xbox is streaming, and it's going to show us, OK, this is what happens here. If we have to cut a link because we can see something, there's a link that's flapping around South America, we say, what happens if we cut this link and traffic is rerouted around? Will there be any latency? Nope, we seem to have all that in check. So the real-time operations checker is great for like understanding fault injection, but at the same time as well, when we want to add and remove things in real time. The last one, we try and de-risk changes by removing humans from the equation, but humans are part of Azure. We need to make changes. Humans need to be there. And if humans do kind of fail, and we try and want to minimize the amount of human contact areas onto our network. David, you want to tell us more about our geos and zones?
Yeah, so for folks who have been using Azure for a little while, this you might be familiar, but for folks who are new in the room, just a quick tour on terminology here. As we zoom in within our network, our wide area network, we get to geographies. Geographies are these groups of regions that are generally defined by a data residency boundary. And generally speaking, we make sure that in each geography, we've got at least one region that's equipped with availability zones, which you can see on the diagram here. If we zoom in, a region itself is one or more data centers, and they're generally that fixed metro-level boundary. They're named after a city usually, except for in the US where we decided to be more interesting. And you can see a little note on the slide here. You can see we've got a defined latency perimeter. So these data centers and zones that make up a region are generally within about 120 kilometers of each other, so we can make sure that we've got that synchronous replication within the region. And then finally, we've got availability zones, which is physically separated clusters of data centers here so that they can have completely independent power, networking, and cooling. Those three are really important because they're the big data center level failures that happen a lot, right? This building lost power, or this campus lost networking. You know, cooling is a big one. If the chiller units on the roof of this particular data center were struggling in terms of cooling that data hall. And so by expanding your apps and your services across multiple availability zones, you de-risk the chance of those things actually causing impact to your production users. If we zoom in further within a region or within an AZ, we get to our data centers themselves. Obviously, we've got what I like to call the obvious redundancies. We've got redundant utility feeds. We've got generators. We've got arrays of batteries. The batteries come on instantly to hold the load while the generators spin up. We keep about 48 hours of diesel on site for the generators, and we're high up on the list behind hospitals to make sure that we can get diesel early in the event of critical infrastructure damage because of how many government services and big companies kind of rely on our cloud and our data center. Quick mention for the Open Compute project. A lot of customers are familiar with the fact that we open source software designs. Maybe you didn't know we open source our hardware designs as well. Everything from the building for the data centers themselves, which originally we borrowed from Boeing. They're good at building big aircraft carriers that don't need big aircraft buildings that don't need support pillars. So we borrowed those initially, all the way through to kind of specific server specifications. It's all open source through the Open Compute project if you want to take a look. So really that helps improve reliability and security because we can learn from the community and make improvements. It's not secure or reliable because of some secret source that only people in Redmond, Washington know. And then the last point on here, we've got great on-site data center teams, but they're backed by our global team of experts, including we use cool things like HoloLens 2, so that if the on-site data center technicians are doing some maintenance or audits, we can make sure that they're looking at the right box or the right rack, and so it gets fancy there. If we zoom in even further within the data center, I wanted to touch very briefly on our storage protections. LRS, ZRS, and GRS are the storage account redundancy options. We store every piece of data in triplicate in Azure. We're going to have a little look at zone redundant storage in a moment. If you use geo-redundant storage, you make sure that we can copy that data across multiple regions. Obviously, that might be a 5 or 6 minute delay depending on the asynchronous nature of replication there. But even if you're just using the bog standard LRS, the cheapest default bottom of the rung, we still keep multiple copies of the data. It just so happens that those copies might be in the same data center. We also want to provide services to help you prevent against accidental deletion. And so that's where we've got, folks should be familiar with role-based access control. But with a combination of immutable storage and forced retention policies, you can make sure that you don't have, as one of my customers did, accidentally have an intern or somebody delete a production system with 20 million users. And you can make sure that, for example, if you're required to keep data for regulatory reasons, even if you go in there as the service admin with superpowers, we won't let you delete it. That retention policy will tell you, oh, no, you're not meant to do that. So we can make sure that you're not playing a game of stop hitting yourself, and we can protect you from your staff or from your partners here. And then lastly, we've got Microsoft managed failover and customer managed failover. Generally speaking, our guidance is to make sure that for storage accounts, you plan to use customer initiated failover, so you can do it at the storage account level. Microsoft will really only do our Microsoft failover in the event of an extreme kind of region down scenario. That's not something we can do at a super granular level here. So that's a very quick flying tour of some of those investments. I wanted to leave you with this diagram that helps to explain the different blast radius of problems that could besiege you on the Azure platform. You could imagine at the smallest level, you could have an isolated VM failure caused by some kind of a hard disk issue. That's something that could happen. Worse than that, you could imagine an entire rack going down. We talk about problems with power or networking that impact a single rack of the data center. Worse than that, we've talked about these data center level failures, right? A power or a networking issue that impacts the whole building. Worse than that still, you could imagine a natural disaster that impacts a region as a whole, not just the individual kind of data centers within it. All of that's to do with your infrastructure, your applications. Obviously, you've got these kinds of problems that can attack your stateful data, corruption, ransomware, things like that. And if we have a look at the resilient services that Azure provides to protect against these, how do you protect against the disk issue? Well, you could upgrade to premium storage. We'll give you a better SLA, and that's less likely to be a problem. How do you protect against a hardware failure in a rack? You could use old school availability sets or some of the new VMSS Flex stuff to make sure that you can spread your workload around within the data center so that it's not in the same rack necessarily. How do you protect against a data center failure? Well, that's where we'll do a lot of demos on availability zones to make that real for you here. And then how do you protect against a region level failure? That's where you'd use Azure Site Recovery or some of those region pair technologies to make sure that even if you need to run away from the region as a whole, you can still be protected. And finally, for stateful data, we've got Azure Backup and a bunch of very capable third-party tools that make sure you can always restore back to a previous copy of the data. So whether or not you're trying to invest in high availability or disaster recovery or backup, we've got the right kinds of solutions here that you can turn on and the right guidance to make sure that you can implement it appropriately. So to make all of that real for you, I'm going to hand over to Sujay, who's going to run a few different demos based around this availability zone construct. Sujay.
Thank you, David. Azure now has availability zones in all major regions and geographies. And we recommend customers to use availability zones to get high availability as well as high resiliency for their applications. Now, you might have applications running on regional virtual machines from a long time. Now, how do you migrate them to zonal configurations? We now have a capability that's recently announced in general availability, which will help convert your regional VMs to zonal configurations in a quick time with minimal downtime. Let me show how you can simply convert your existing regional VMs. On the VM menu in Portal, go to Availability by Scaling, and then click Get Started. You can select a target zone of your choice, and then click on Next. Now, this capability is powered by Azure Resource Mover, which helps identify all your networking dependencies like NIC, public IP, and also your configuration parameters like zone, this queue size, and name. And if you want to change any of your configuration parameters, the target configuration, you can simply click on Configure. For example, you want to change the virtual machine name or the size of the virtual machine. You can change and save those settings. Once you review all the settings, you just click on Move. This process is going to take a few minutes where in the background, the original virtual machine is stopped momentarily and a copy of the virtual machine is created in the target zone without any data loss. Once the target zone machine is available, you can verify your application is running fine, do all the validations you would want, and then go back to your source virtual machine and delete it. Now I'm going to show you different application patterns that you can leverage for your applications to get high availability and protection against zone failures. The first of them is the active passive deployment with VMs using ZRS disks. ZRS, or zone redundant storage, replicates the disks continuously in a synchronous manner across all the 3 zones, so that the disks are available even in case of partial or full zonal outage. And you can get your app up and running without any data loss. I have a Conteso order processing application which is running on Zone 1 VM, which is also using ZRS data disks. To simulate a zonal failure, I'm going to stop this machine. Since this machine is using the ZRS data disks to store all the app configuration and data, even if this VM is impacted, you will not lose any of that. Now I'm going to use a new capability called force detach, which will help you detach this ZRS disk and use it on another VM in another zone when in the event of any outage. I'm going to detach this disk. And then I'm going to use another VM, which is a standby VM in zone 2, and going to attach the disk we just detached. I'm going to use a pre-configured LAN ID. You can see the disk we just detached from the previous VM. You click on Save. Now if I refresh this application, it has been down since we shut down the original virtual machine in zone 1. Now since I reattached the disk, and this application is also configured with zone redundant networking load balancer, which will configure the traffic from VM in zone 1 to zone 2 in case there is an issue in zone 1. Now let me refresh and see. There you go. The VM is up and running fine without any data loss, and your order processing happening continuously. The second pattern is using Azure Site Recovery for your VMs with LRS disks. Azure Site Recovery is a hero VM disaster recovery solution across regions, and the same also supports cross-zone disaster recovery for your VMs. Using capabilities such as DR stressed failover and pre-configured networking settings in the target zone, you can achieve minimal downtime and minimal data loss-based recovery for your VMs and apps running on those VMs in case of zonal issues. The third pattern is the active deployment using multi-zone spanning virtual machine scale sets. You can deploy your virtual machine instances in a scale set across 2 or more availability zones and ensure that in case one of the zone is out, you still have the other VMs in other zones servicing your requests. For this demo, I have an order processing website again, which is deployed, whose front end is on VMSS instances across zones, and the back end is running on Azure SQL database with ZRS configuration. You can see that I have 3 VM instances deployed across 3 zones, and that is what is powering this application. You can also see for the demo which VM is servicing the request. For example, if I refresh the website, you can see the zone changes. Now, to simulate the zone failure, I'm going to bring 2 of the machines down. Now, if I refresh the website, it will still continue to run with the only VM that is running in zone 1. So using this active-active configuration, you can have your applications continuously running even in case of zonal issues. Over to you, Sami.
Super, thank you very much. And Sujay, I think you're brave doing live demos because live demos are always very touch and go, so congratulations. It's not only outages that can interrupt applications, outages are a part of it, but also when we have all our hosts, if we look at the ingredients of Azure we were talking about earlier, at the very kernel is compute. And everything sits on compute. And so if there are interruptions to compute, which there will be because no one's created the rebootless cloud just yet, it can cause interruptions to applications. Some of the steps that we're taking is to create these kind of create micro updates that don't disrupt, or create very, very hot patching, which is less than 20 seconds, or if we have to upgrade a host, or worst case, if we see a host failing and we have to live migrate the guest, we can migrate the guest without causing too much interruption as well. Our physical host updates, our VM FOOs, are just under 30 seconds as well. So the idea is that over time, we're making progress in terms of creating these impactless updates. One of the things that there's no detail on the slide because it happened very, very late in the game, but I was informed in October, we used to have these TORs, these top-of-rack switches. And these top-of-rack switches would require updates, and those updates would be felt by the VM. What felt like it could vary per VM and per workload. But now we've updated, there were tens of thousands of these. They would touch millions of VMs across Azure. And I was just told that come October, we had closed out replacing all of these with our own operating system of Sonic, where we partnered with our vendors, and we've replaced all of this hardware. So we can now create these impact-less updates to our top-of-rack switches without any impact to the VMs, which is progress in the right direction. Moving away from the core ingredients of Azure, now we have 200 services plus that sit on top of Azure. And we need to think of ways in which we manage these so that there isn't much disruption to customers. With these 200 services that sit on top of Azure, 200 plus, I don't know the number now, it keeps changing. But we have 3 general rules. We want to make changes very safely. We want to make sure that if there is an issue, and we're talking about the 0.002% of the time, or 1/500th of 1%, however small it is, it can be really impactful. And so those blast radiuses need to be tight and small and not broad. And then lastly, these PaaS services, a lot of them are worker roles, they should have resiliency built in them. It shouldn't be that one instance goes down and it impacts the entire PaaS service. And so if we focus on change for the moment, we first have to ask ourselves, why change has to happen. And change is a necessity of the cloud. We need to keep the world secure. We need to make updates. We need to ship the latest and greatest features to our customers. And so change has to happen. And just as a contrasting story, David and I remember we went to a customer site where they were on-prem at the time. We weren't 4 nines and an 8, but we were talking about their uptime. And he said, Sami, David, I'm at 100% uptime. We said, it's incredible. And later on, as we started speaking to people in their organization, the security IT department were terrified because it hadn't been patched since Spectre Meltdown. The users were upset because they didn't have the latest and greatest software. Everything felt antiquated. And so that 100% uptime, it comes at a cost. And so we need to kind of create these changes. But the way we make changes in Azure has to be staged, and it has to be managed very tightly. Inside our validation circle, that's the kind of stuff that goes on inside the house. But when we start deploying, we deploy in a very, very slow fashion. And when we send our payloads out, it usually starts in one server, in one cluster, in one region, and it bakes. And we just kind of monitor. And we make sure that, and then it doubles over time, and it doubles over time. It's kind of like a virus. And it kind of keeps spreading, and then it goes from one zone to another zone. We don't update zones at the same time, because if there is an error, or if there's a bug we run into, we want to make sure that zonal resiliency works. We also don't upgrade region pairs at the same time as well, because we want to make sure that if customers are leveraging region pairs, they're not impacted. At any point in time, if we detect any anomaly, we pause the deployment, we either roll back or we hot patch forward, but we do these things in very slow stages as not to impact customers. One of the things where I feel like we almost went back in time, just before we kind of transitioned into the public cloud, we used to just kind of let the system handle it. But we've introduced a new step, it's called Ready to Deploy, and this is almost like a change advisory board. There are humans involved in this. This isn't a system thing. But for high-risk workloads, when we look at things, we say, OK, well, what's going on here? We'll actually have a committee of people sit down and say, show me your test data. I'd like to take a look. Show me where you've used fault injection here. What happens when you roll back? I want to see it in action, please. Don't just take your word for it. And we found that those human steps and kind of having the top leaders of the world press each other and make sure everything's checked, we've reduced the number of change-related outages that have happened. Because of the way we deploy change in that slow, baked fashion, most of the outages that we have impact a very small number of customers. I say this, I mean toes as well, fingers and toes. A small number of customers, and we're able to detect test and kind of take mitigating action there. David, can you please talk to us about the other things that we use in processes?
Yes, Sami talked a little bit about how we use humans here in addition to automation, and I'd rather talk about the automation because one of the big things that we like to talk about that helps with the reliability is using artificial intelligence. And so Gartner termed this coin AI Ops, which I think is a cool way to describe it, which basically means humans can't reason over this. My favorite statistic in this whole presentation, 68 petabytes of logs are generated by the Microsoft Cloud every 24 hours. Now that's everything. That's Azure, that's Microsoft 365, that's Power Platform, everything that customers do, just the logging alone, 68 petabytes. And so you can imagine, some poor person on call wakes up at 3 o'clock in the morning, splashes water on their face, okay, I'll go read these logs and figure out what's happening. That doesn't really work. And so we have to ingest these into systems that can reason over it. So we ingest this kind of data, what's happening, who's deploying stuff, where are all these changes that Sami talked about in the process of rolling out, and we can both seek insights, hey, are there problems happening, why is that happening, and even automate actions to mitigate things. And so as 3 quick examples of AI Ops in practice, we do things like pre-provisioning VMs. It used to be the case when I started working on Azure in 2010 that if you asked for a VM, you'd go away and make a cup of coffee because it might take 5 or 10 minutes. Since then, AI Ops knows how many people are spinning up a DV2 in Australia East, and we can go pre-provision that. Here's one I prepared earlier, so that a VM takes no time at all. That's just a really helpful example of AI helping to improve the experience. Secondly, we've got anomaly detection. Obviously, you can draw your own line in the sand in Azure Monitor, alert me if things get above this threshold, or you can just leave that up to AI. You can say, hey, you tell me if it's anomalous, and we'll let the AI Ops go and figure out if there's something worth flagging to you. That's available now with the dynamic threshold feature. And then lastly, Project 𝗦𝗲𝗀𝗃𝗃 is an internal system that we have where we talk about the types of host failures that Sami mentioned, and we said, we're not going to have humans here. You as the AI system, you go and figure out which of these different mitigation strategies make sense for which host failures. And it runs a bunch of A/B tests, and it comes up with, okay, and this kind of thing, well, last time that happened in Singapore, we did this, and so we can actually start working on reducing VM interruptions that way. And since this has been running in production, we've brought those VM interruptions down by 26% running in production. So 3 quick examples of using AI. Well, a bonus example I'll throw in, because if I mention AI, people are thinking LLMs. I know there's a lot of talk about Copilot and ChatGPT recently. We've started to use large language models to listen in on our incident bridges or our incident calls that we have internally when we're mitigating and troubleshooting problems. We use something very similar to it's a ChatGPT-based Azure OpenAI service that ingests all of the transcription logs live from our incident calls. So if I'm on call, and I'm going to be on call on Monday, when I open up our incident management tools, I can actually see a summary of what the folks on the bridge are talking about live. None of them have gone and entered that into a tool. Nobody's taking notes. It's just the AI system summarizing stuff. And then I can use Copilot and Teams to ask follow-up questions. Hey, what did I miss? What did 𝗦𝗽𝗲𝗀𝗃𝗀𝗀𝗃 say about comms a half an hour ago? And actually interact with it, and I'm actually interacting as if I were on that bridge, which I think is a cool way of using AI. Another group of investments that I wanted to touch on is Project Dial Tone. We've got teams of people that focus on what are extremely rare but would be really, really bad scenarios. So this isn't traditional DR. This is like, what is the worst of the worst? What if there's a Windows 0-day fault that impacts our DNS stack? Well, we've got a redundant DNS stack that runs on Linux so that it can be separated. Or especially for customers on the bottom here, hey, what if Azure Service Health alerts are impacted by an Azure outage? How do we send off a beacon and let you know that there's an outage if that's built on Azure? And so we've got a bunch of systems that aren't reliant on Azure itself. We used to have things like the Azure status page, the public page that would be brought down by an outage, and we're slowly over time making sure that service recovery is always possible and that critical communications can always work here. But this is talking about Azure across the board. As you know, Azure is 200 plus different services, and as Sami will explain, they're a little different from one another.
Thank you. The 200 plus services, and this is almost like manage 200 different egos or children. I mean, everyone's doing their own thing. And so if we're going to build reliable, dependable systems for our customers, we use these ingredients in these services ourselves. We look at HD Insight, it's made up of internal stuff, and it's the same APIs and everything the customer's using too. So that standardization and that predictability is super important. I would be lying if we said, and we in Azure are around here. It's not us in Azure. There's 200 services, and different services are at different stages of the maturity model. In general, for the most part, they need to be rotating certificates the same way. We find that services customize the way they do things because it suits them very well, which is wonderful. But as our SRE teams go into there and they look at this and they say, well, I mean, if we do this here, and it works here, and it works here, and it works here, this is now a standard. And we need to we are building standards around throttling, retry, back-off logic. I mean, how we provision and how we leverage these APIs. So it's a work in progress of but these are the kind of areas that we're making for the 200 plus services to try and be homogenized. We've moved away from our ingredients and our processes, and our principles really kind of govern how we do things on Azure as well. And so I'd like to speak about some of these. Security over reliability. I mean, you've heard Satya talking about if there's an option between security and something else, pick security, and he always says this. And it sounds like a wonderful tagline. Of course, security first, it's wonderful. But at times, it can impact reliability. And I remember during the Spectre Meltdown issue, I don't know how many people are familiar with Spectre Meltdown, but essentially there was a zero-day threat that we had been preparing for some time. We won't go into a huge amount of detail now, but we had patched our fleet, and the last bit that was remaining were IaaS VMs for customers. And so pretty much with no notice, we needed to reboot those IaaS VMs to get them onto patched hosts so that we could patch the hosts that they were sitting on, because we didn't have the microcode updates that we have today. Anyway, because of this zero-day threat that was out in the wild, we ended up aggressively rebooting huge chunks of our fleet to get these IaaS customers onto PaaS services. And while, at the end of the day, we could boast security over reliability, it was extremely painful for our customers who had almost no notice and being rebooted. Another one of our kind of principles or philosophies is around data integrity over availability. Our cloud doesn't like to lose data, and for some customers to say, of course, this is wonderful. Data retention is fabulous. But at the same time, going back the same year of Spectre Meltdown, in 2018, we had a major outage in our South Central US data center where, the chillers went down, the data center heated up to a point where it thought it was on fire, it got evacuated. The heat was so high that, permanent damage had been done to huge amounts of hardware in that colo, and our engineers were literally going in and recabling stuff. And customer impact was broad, but customers fell into two categories when it came to storage or data availability. They said, some customers said, fail me out of the region, I don't care, I need to get back online. And other customers said, don't you dare fail me out. I am highly regulated, I can't lose 1 second of data. And so our stance is, we're not going to lose the data, so it's going to be a longer time to recover. And so some customers endured a longer outage because of this. Since then, we've given customers a storage-initiated failover, which David mentioned, and customers are able to pull the lever themselves and throw away the last few minutes of data. When it comes to it being in that 0.002% or the 1/500th of 1% of an outage time, we do have kind of principles on how we communicate. And here, we don't believe our competitor is AWS or GCP when there is an outage. Our competitor, when there is an outage, is on-prem. Because when customers have an issue on-prem, they know what's going on, they have updates, their CEO's in the know, everyone's getting the right emails. But an outage in the cloud can feel very, very different. And so we built these kind of 5 principles to guide us through this. The first one is around speed. Is it a me problem or is it an Azure problem? And David mentioned some of the work we're doing in AIOps. Brain detects and communicates 75% of our outages, that initial communicating, saying, hey, it's an Azure problem, and it will send that to impacted customers only. The second one, if you're running 10,000 virtual machines in East US 2, and we're having an issue with virtual machines in East US 2, you'll need to know which one of your 10,000 virtual machines are impacted. Is it my production? Is it my dev test? And we use resource health in order to kind of emit that signal. The third one's around discoverability. Too many people go to the public status page, and they say, just to check if there's any outages. We use that page less than 1% of the time. We're very public about when we use it, but all communications to impacted customers will be in service health, where customers can set up last mile notifications. If you want to use email, SMS, a logic app, functions, API, webhook, you name it, but the idea is go into service health and create that last mile for yourself. When we talk about parity, customers buy the Microsoft Cloud, and it sounds amazing. And then they open the box, and there's an M365, a Dynamics, and an Azure, and it doesn't always fit together as nicely. And so in the outage space, we're trying to harmonize the experience so it feels like there's one company, there's one response profile. And lastly, I'd like to speak around transparency. We're trying very hard to dial up our efforts in transparency to tell our customers not only what goes on during and offer everything we know, like ETAs and what we think it is, but also following. And this is where we've made a huge amount of progress. And the reason I like this kind of shot is because following our major incidents, and you can see this on our public status page, and for other incidents as well, we'll send an invite to all impacted customers, and we'll say, hey, if we've published the PIR, come and join a live stream call where customers can join live and have their questions answered, and you'll hear from the leaders, usually the corporate vice presidents of these services, around what happened and what went wrong. Customers can ask questions and engage with our leaders about this. And we really think this increase in transparency is a core ingredient for building real trust. All of these lofty principles sound wonderful. Azure Service Health is the place where to go, where customers can get invites to these things, they can get the post-incident reviews, and they can get notified for outages. Now, creating these alerts are easy. I think most people can set up an email alert, but doing this at scale can be tricky. And Sujay, could you please walk us through how to do these kinds of things at scale?
Thank you, Sami. This is the service health page in Azure portal, where you can track various service issues, the plant maintenance activities, or any advisories, and all the things across your resources, across subscriptions, and multiple management groups as well. Now you might be wondering, I have a lot of these resources across my estate. How do I configure alerts? What do I even track? That is where we have something called Azure Monitor Baseline Alerts, which will configure all the required alerts on your resources and subscriptions at scale with a few clicks. To demonstrate that, I'm going to use the Monitor Baseline Alerts Accelerator portal, where you can select the scope on which you want to configure your alerts. I'm selecting a management group. And then you can review any settings. If you want to change any optional parameters and configuration, you can do that. And then go to the notification settings. This is where you can provide the email IDs where you want the alerts to be sent. You can also configure a webhook URI endpoint to your ITSM system. For example, if you want to configure something to your ServiceNow so that it can trigger a service process that your organization has based on an incident, that can be configured. Once you review all of this, you click on Create, and within a few minutes, the alerts are going to be set up across subscriptions. For the demo, I have pre-configured alerts across a management group. This is how the alerts are going to look like for a bunch of subscriptions which I already pre-configured. So you don't have to worry about each and every alert to be configured. All the baseline alerts are pre-configured for you. If you want to make any changes, you can go ahead and do that. Last but not the least, I'm going to show you how an email alert is going to look like. This is a sample alert that got triggered a few days back. All you have to do, you can connect it to your ITSM systems and then react to it, or you can go to Azure Monitor, do further troubleshooting and all. So this is one of those sample alerts. Over to you, David.
Cool. Thank you for that, to make it real there so that you know what's happening. Sami and myself and our team, we work on call as communications managers, explaining outages to customers, and you have to make sure that you wire up that last mile delivery so that you get it and the relevant people in your organization get it. We've touched on some of these, but really I wanted to focus on your responsibility as far as reliability in the cloud. Some of the demos have helped with these features, but I wanted to mention the other resources available to you as you start to navigate this kind of area of beefing up your existing workloads in production systems using Azure. And so a lot of that's going to depend on the availability needs of your application. It depends whether or not you're running batch processing overnight, and if it gets interrupted, nobody loses sleep over it, all the way up to ATMs or elections or hospitals, where it becomes obviously a lot more important here. And so our initial guidance is not to go after a fly with a bazooka. You don't want to approach every single workload that you have in Azure from the perspective of 100% active, GRS, everything. That really would be overkill for a lot of these scenarios. But where it's important to you and where it's important to your users, that additional cost and additional complexity architecturally is really helpful to understand. And so there's a lot of different resources available to you. I wanted to make a shout out for Azure Essentials, which is a really good starting place to make sure that for reliability as well as security and performance, that you can understand how to assess your current state and then identify your gaps, how to prioritize those so you can get the biggest bang for your buck, and then ultimately how to remediate those. And we've got teams of people that can help you as well as helpful tools. My favorite that I wanted to mention is the Azure Well-Architected Framework. I'm seeing a couple of people nodding, so people are aware of this. There's 5 big pillars here, one of which is reliability. And that's where we get into reference architectures and assessments that can really help to get specific around any specific workload that you're running in Azure to give you the best guidance in terms of how to start implementing some of the technologies that we're looking at here at the moment. Within the well-architected framework, there's a lot of guidance there on design and validation. And so I wanted to touch on chaos engineering. This is something that, this is where the rubber meets the road. It's all very well and good to think, in theory, yes, your application is designed to handle this or that or the other. Chaos engineering, and particularly Azure Chaos Studio, which is our flavor of this fault injection technology, is where you really get to test out whether that's true. You might have confidence in it. Well, this is where you'll find out for real by going and injecting those faults and testing those failure modes that you've planned to see whether or not your app survives it. Whether or not you're doing that in a dev test environment just as some validation before launching a product, or if you're actually running this in production so that you've got extra sensors to go off as you randomly go and implement faults and destroy things. things. I think that it's a really helpful way of looking at it. And so in one of Sujay's previous demos, we went in and just kind of stopped the VM to simulate it. But I wanted to give Sujay a chance to take it to the next level and briefly use Chaos Studio to start injecting some faults and make it real. Sujay.
Chaos Studio lets you inject faults into different resources of your applications and then see how your applications behave in real time to these faults and be prepared for outage days. Now, Chaos Studio is very simple to use. The demo I'm going to do is the previous demo where we simulated zonal outages. We are going to use Chaos to inject VM shutdown failures into the applications and see how those applications behave. The first step is to select the target, the virtual machine where you want to enable this fault. Click on Service Direct Targets, and then click on Review and Enable. Once you have your target already added, the next step is to create a chaos experiment where you can control how you are injecting faults into your resources. Click on New Experiment. Give it a name. Next, you go to the experiment designer where you can configure various actions or faults you want to induce. For this demo, I'm going to select the VM shutdown fault. You can see various types of faults you can induce across different resources. I'm going to pick the VM shutdown. You can configure parameters like how long you want the fault to be and whether it's a graceful shutdown or an abrupt shutdown, and then select the VM you want to induce the fault. For your complex applications, you can induce different kinds of faults using this experiment designer view. And then once you're ready, you click on Create. For the demo, I already have a pre-created experiment. And to start an experiment, you just have to right-click and start the experiment. To recap, you can configure different types of experiments for your applications. In this demo, I have configured a VM shutdown failure to simulate a zonal outage. And this is going to bring the VM down. And then you can test how your application works. If you have recovery mechanisms configured, test those recovery processes, and be prepared for any outage days.
Cool. Thank you, Sujay. So we're on the home stretch here. It's very hard to take the last 45 minutes and put it on a single slide of what I would like each of you to go and do, but here's my best attempt at it. Optimizing the reliability of your critical workload should be step one, right? We keep saying outages are inevitable. Impact doesn't have to be. And so if you've architected to ensure that you can survive a zonal failure, you'll survive a zonal failure here. That's got to be the first step. We've obviously talked about communications, and so familiarizing yourself with Azure Service Health in the portal is a great starting point. But really, we'd rather that be pushed out to you than you have to go and pull it. And so Azure Service Health Alerts are the best way for you to wire that up, as Sujay showed. Resource Health Alerts are really great for getting a literal live up-down blip on any specific resource that's really important to your criticality. It can be a little noisy sometimes, but in combination with Service Health Alerts, it's a helpful signal. And then scheduled events is a great way for your VMs to know that something bad is happening. Sami talked about maintenance events, or if we're having to take something down for an update, or if you're on a bad host, and you can actually get 10 or 15 minutes notice through that scheduled event to tell your VM, hey, something bad's going to happen to you. Maybe pull yourself out of rotation of the pool so that doesn't become impactful. During an incident, Service Health is the one-stop shop. If there are ever issues accessing Service Health, if there's an Entra ID thing or a portal issue that actually stops you from getting there, then we use that public status page that Sami talked about. And as our backup, in case that ever doesn't work, we've got the @Azure Support Twitter handle that we use to post updates on X. A very last point on here, it's not super helpful to contact support if you're already receiving the comms about an outage. Support isn't going to have more information than we're communicating to you. But if you're seeing something different, if you're saying, well, you're telling telling me there's a VM issue in Australia East, and I'm actually seeing problems in Southeast, absolutely contact support. That's a good signal for us. Maybe we're wrong, or maybe it's something unrelated. And especially if you're trying to implement some of the failovers that Sujay showed, hey, I know about the outage, I've read about it, I'm not looking for more information, but I'm trying to implement my failover lever and it's not working, our support teams can absolutely help you to implement that. So this is times when it actually does make sense to contact support. And then very lastly, we've got a couple more sessions that are coming up at Ignite. Sami and I are running a session tomorrow morning that's going to focus even more on the communication side of things and transparency, how we're running our live streams, how we make sure we get updates out to you. And so that's top of the list. We've also got some hands-on labs and then a session on Friday that's really going to help with your resilient workload. So we're running out of time here. We're happy to take questions afterwards. But thank you very much for joining us this morning. Thanks, Steve.